Have you ever picked up a piece of styrofoam? It feels almost like nothing, doesn't it? It's light, it's white, and it's full of… Well, what is it full of? It's mostly air. Imagine holding a solid, puffy cloud in your hands. Now consider this, what if we could take all the air out of that cloud? What would be left behind? Would it be a tiny, dense little rock? Could we squeeze a giant block of styrofoam down to the size of a small piece of candy? This might sound like a magic trick, but it's not magic at all. It's science. And today, we're going on an amazing scientific journey to do just that. We are going to explore the shocking, surprising, and frankly super cool truth about styrofoam. We're going to see how this incredibly lightweight material can be transformed into something completely different. It's a process that reveals the hidden nature of the things all around us. By using a few simple household materials, we can unlock the secrets trapped inside that puffy white packaging. This experiment will change the way you look at that takeout container or the protective foam around a new television. It's a hands-on demonstration of chemistry in action, and it's something you won't soon forget. So, get your science goggles ready because things are about to get interesting. So, what exactly is this styrofoam stuff? The name we use is actually a brand name, like Kleenex for tissues. The real scientific name is expanded polystyrene. Let's break it down. Poly means many. Styrene is a type of molecule. Polystyrene. Many styrene molecules linked into a long chain. Think of it like a super long necklace of tiny beads. That long chain molecule, the polymer, is the basic building block. But if it's plastic, why is it so light and puffy? That's the expanded part. Tiny polystyrene beads are infused with gas. Heat and steam make the gas expand. The beads puff up like popcorn. Puffed beads are pressed together in molds into blocks. The final product is about 95% air. Only about 5% is actual plastic. The trapped air makes it a great insulator for hot drinks. It also makes it an excellent cushion for shipping fragile items. Coffee cups, coolers, packaging, protects new computers, packaging, protects televisions, packaging, protects other delicate items, construction insulation, craft projects, floating docks, very buoyant. But there's a downside. It's lightweight and bulky. It doesn't break down easily in nature. It fills landfills. It breaks into tiny pieces that pollute oceans. It can harm wildlife. Understanding what it's made of is the first step to better recycling and disposal. Our experiment today will show the plastic hiding inside that trapped air. Now let's get to the main event, our grand scientific experiment. Mission: transform styrofoam. Not just crush it, not just break it. Chemistry will force a radical transformation. Take a large, airy chunk of expanded polystyrene, turn it into a small, then dense, then colorful solid. Not any solid, something that looks swirly, reddish-brown like cinnamon hard candy. It's a visual trick, a scientific spectacle, a powerful lesson. Like being a science magician. Watch a solid practically disappear into a liquid. A big pile of packing peanuts shrinking into a tiny puddle of goo. It seems to defy logic. How can so much fit into such a small space? The answer? Release the trapped air. Deflate the styrofoam at a molecular level. Leave behind only plastic polymer chains. Why cinnamon candy? Because science should be fun. We could make a plain lump of plastic, interesting sure, but add color and shape it right, and the science becomes unforgettable. Before we mix, pour, or dissolve anything, we have to talk about the most important part of any experiment: safety. Science is amazing, but it requires us to be responsible and careful. We're going to be working with a chemical called acetone. It's common. It's the main ingredient in many nail polish removers. However, just because it's common doesn't mean we can be careless with it. It's a powerful solvent. Wear safety goggles, essential. Wear gloves like nitrile. Work in a well-ventilated area. Open a window or do the experiment outside. Acetone fumes are strong and flammable. Materials: styrofoam, packing peanuts, takeout container, foam block. Acetone, a glass jar or metal bowl. Do not use a plastic cup. Red and brown food coloring, and a wooden stick. Never perform experiments without adult supervision. With safety gear on and the mission commander ready, we are prepared. Alright scientists, it's time for the action to begin. We have our safety goggles on, our gloves fitted, and our well-ventilated space ready to go. Take your glass or metal container and place it on a flat, stable surface. Now pour a small amount of acetone into the container, about an inch or two deep. You'll notice the strong smell. That's why ventilation matters. This clear liquid is our powerful solvent, the key that will unlock the air from our styrofoam. Now, for the magical moment. Take your first piece of styrofoam, a packing peanut or a small chunk, and gently place it onto the surface. Watch closely. The moment it touches the liquid, it will fizz and shrink, almost as if it's melting away into nothing. It's immediate and dramatic. Keep adding more, a huge pile will dissolve into a small amount of liquid. As it dissolves, the liquid becomes thicker and gooier, turning into a thick, sticky slime, a concentrated solution of polystyrene plastic. All the air, about 95%, is released. What's left is the 5% plastic now dissolved in acetone. Stir gently as you add foam, eventually the solvent becomes saturated and very gelatinous. So what scientific sorcery just happened? Not sorcery at all. Styrofoam is polystyrene, a polymer. Acetone is a nonpolar solvent. Polystyrene is nonpolar too. Chemistry rule, like dissolves like. Acetone molecules wiggle between the chains, loosening the foam structure. Trapped air rushes out with a fizz. Chains collapse into a gooey mess. This is a physical change, not a chemical one. The polymer isn't turned into something new, it's simply rearranged. When the acetone evaporates, the chains tangle back into a hard, non-puffy solid. We've taken the expanded out of expanded polystyrene. Isn't that neat? We've successfully dissolved our styrofoam and colored our goo. Using your wooden stick, carefully lift the glob out. It'll be sticky and stringy like melted mozzarella or taffy. Have a non-stick surface ready, aluminum foil or wax paper, so it won't get permanently stuck. Carefully place the blob and start to shape it. A small flat disc like an old-fashioned hard candy, or a twisted shard. As you work, it gets less sticky and more firm. Acetone is evaporating, leaving polystyrene behind. Keep that ventilation going. Now comes the waiting part of science. Leave your shaped candy to dry completely, several hours or even a full day, until all acetone evaporates. As it dries, the goo hardens into a solid, brittle plastic. You'll be left with a hard, reddish-brown object, dense. Tap it and it clicks. After waiting patiently, let's take a look. What you have is a small, hard, translucent, reddish-brown piece of plastic. It's dense, it's solid, and it looks remarkably like a piece of cinnamon hard candy. It's hard to believe it used to be a giant, lightweight pile of airy styrofoam. Now this is the most important warning. I have to say it loud and clear. This is not candy. It is absolutely, positively not edible. It still contains residual chemicals and is dangerous. Eating it could make you very, very sick. The cinnamon candy name is just for fun. This is a scientific specimen, not a snack. Our look-alike is a fantastic conversation starter. Show it to friends and ask them to guess. Tell them it used to be a huge pile of styrofoam. Then explain, it's mostly air. A solvent like acetone releases the air and leaves concentrated plastic. So there you have it. We took something ordinary, something most people throw away without a second thought, and transformed it into something extraordinary. We turned a puffy white cloud of styrofoam into a dense, colorful piece of cinnamon candy. We've peeked behind the curtain of material science, seen how properties relate to structure, and how chemistry can change them. It all started with a simple question. This journey was powered by curiosity. I wonder why that happens. What if I tried this? Why is styrofoam so light? What happens when it gets wet? Or when it's wet with something other than water? Every discovery, gravity, electricity, DNA structure, began with curiosity. Never stop asking questions, look and wonder. Remember safety. Wearing goggles, working in a ventilated space, having adult supervision. Safety doesn't make science less fun, it makes it possible. Safe science is smart science. Our styrofoam experiment is one way to see science in action. The world is your laboratory, bread rising, a rainbow in the sky, chemistry and physics everywhere. Keep that curiosity alive. Read books, watch videos, try safe, simple experiments at home with a grown-up. Go out there, be curious, be safe, keep exploring. Science is all around you.